My name is Ian Gaffney. This is Physics 2211, Lab number 3, Black Holes. I hope everyone had a great weekend and are having a great day today. Let's get started. Okay, so what's the purpose of this lab? So for part 1, we're supposed to determine the mass of the black hole by analyzing a star's orbit around it. And then in part 2, we're supposed to determine the minimum velocity needed to allow a rocket to enter the black hole's orbit without crashing into the black hole or the planet that it's leaving from. Um, and then the principles that have been being used are the force of gravity, so the g/mm over r squared times r hat right here. We got the position update formula, and an extension of this would be the velocity update formula as well. And then we also have dp/dt formula, so we have the parallel and perpendicular components of this, which are both important to this lab. What are the system and surroundings? Part 1, the system is a star, and the surroundings are the black hole. Part 2, the system is a rocket ship, and the surroundings are the black hole and the planet. Initial conditions. In part 1, the star is in orbit of the black hole. The star's mass and position are known, and the black hole's mass is unknown. In part 2, the rocket ship is initially at rest on the surface of the planet. The planet is in orbit of the black hole. All three masses are known, and all positions are known. Okay, so here's my code for part 1. So as you can see, I kind of just, you know, put in the values for the initial and final velocities and momentums, as well as like the delta velocity and momentum. Um, I said that F net is equal to dp/dt, which is true. And then that's kind of really the only important thing. Here's my mass of the black hole down here. If you want to take a look at that real quick, this mass of the star is given to us, and delta t is the number of seconds in a day or in a year. So this is the part 2 code. So as you can see, mass from the black hole from part 1. Here are all of our constants and masses and stuff that we need to know. Um, and then this is given to us. And then over here, this is where I determined basically the F net on the planet as well as the F net on the ship. So I did both of these basically the same way. So I found the position hat, the force of the black hole on the planet, and then ship on the planet, and then added those up. And the same thing with the ship. And then down here, this were the iterations. So I updated the velocity as well as position after each delta t time step for both the planet and the ship, as you can see. So yeah. Possible sources of error for this would be I did not take the average of the black hole masses correctly from part 1. And then also I could have made some physics mistakes when determining the escape velocity. Okay, so what does it mean? So this is referring to part 1. So F net is a total force acting on an object at a point in time. dp/dt is the instantaneous rate of change of an object's momentum at a point in time, and they're technically the same thing, but they are determined differently. So for F net, you need mass and acceleration or something like that, and then dp/dt is obviously final momentum minus initial divided by time. Okay, so what if this is referring to part 2? So basically, in order for a rocket to escape the planet and get into the black hole's orbit without crashing into either, it would need a velocity of x of negative 0.5 times 10 to the 6th, and then y is 1.2 times 10 to the 7th. Thank you so much. Drop a like, subscribe, turn that post notification bell on, and I'll see you next time.